Hello everyone, I am Professor Ken Oxore. In this today's lecture, we are going to study the helical gear. In this today's lecture, we are going to study the introduction of the helical gear, its advantages and the disadvantages, center distance between the two helical gears. Again, we are going to derive the expression or the relationship between the various forces acting on the gears, and we are going to find out the equivalent number of teeth of the helical gear with respect to the spur gear. That this whole task we are going to study in this today's lecture. Now we'll start with the introduction. In the introduction, that helical gear, that if you see the geometry, you can directly recognize what is the difference between the spur gear and the helical gear. In this helical gear, that teeth are inclined to the axis of rotation, and this total angle, which is referred as a helix angle alpha. Again, in this case, what happened? In the helical gear, that contact between two mating teeth, which starts with the point and which ends just, you'll find just gradual engagement like this, which makes to operate this gear more smoothly and the quietly as compared to the spur gear. Again, one another interesting thing of this helical gear is that, okay, before that interesting thing, see, while meshing the two helical gears, there are some notations for the helix angle. Now in this case, this angle which is referred as a alpha, now this is the right hand helix, and that suppose its orientation which are like this, which is referred as a left hand helix. Every time while transmitting the motion between two parallel shafts in the helical gear, every time we have to mesh right hand helix gear with the left hand helix gear, or left hand helix gear with the right hand helix gear. Again, one condition must be satisfied, which is they must have the same helix angle. Okay, that means first condition, they must have the same helix angle, and second condition, they must have the different hand of helix. Okay, again, I want to transfer the motion between two intersecting shafts. In that case, what we have to do, you have to that engage left hand helix with the left hand helix. In that case, you can transmit the motion between two non-parallel intersecting shafts like this, non-parallel intersecting shafts. And if you mesh that same opposite hand of helix with the same helix angle, you can transmit the motion between two parallel shafts. Same hand of helix, that will find this orientation to non-parallel non-intersecting shafts. Again, suppose they are having the opposite hand of helix, again having the same helix angle, we can transmit the motion between two parallel shafts. In this way, we can achieve that both the cases in case of helical gear. Okay. Next, in the helical gear, there are some advantages and some disadvantages. They run more smoothly and quietly because of that contact starts with the point, ends with the line. Okay. Again, these are for they are having the high load carrying capacity, because that inclination of the tooth, that takes more number of, that means contact ratio gets increases, and because of this, the total load acting on the more number of teeth, and which takes that load. That's why it is having the high load carrying capacity. Again, less wear can be takes place, because again load is distributed over the several teeth. Again, we can transmit the motion between parallel shaft as well as right angle shaft. Okay. Again, so there are some disadvantages. In case of, because of the orientation of the tooth with the axis of rotation, or because of that helix angle, there are three forces acting on the tooth. One is the axial load, second one is the radial load, and third one is the tangential load. The tangential load, which requires to transmit the power; axial load, which tries to separate the distance along the axial direction, or along the axis parallel to the that axis parallel to the axis of rotation. Along that axis, these two gears get separated in case of axial load. And third one is the radial load. Radial load tries to disengage these two gears along the radial direction. That means in this case, only one required force is the tangential force. But again, there are one force which gets added in case of helical gear, which is the thrust load, or the axial thrust. And to restrict that thrust, we need to add one thrust bearing. This is the extra cost that we have to pay when we are going to use the helical gear. Okay, again, because of its geometry, it is having the more cost, manufacturing cost, as compared to the helical gear. Again, because of that inclination, they may have the sliding contact, and because of this, it's because of the friction, that its efficiency gets reduces, and which causes the power loss and the less efficiency. Okay, these are the helical gear. Okay, we can transmit the motion between two parallel shafts or the 90 degrees intersecting shafts, which are referred as a spiral gear, that we are going to study in the next lecture, that 90 degrees non-intersecting shaft, which are the helical gears. Okay, all this we have already studied. Increase the contact ratio, again high load carrying capacity, smooth operation, again close concentricity between the pitch diameter and the outside diameter allow for the, okay, that we have already studied. Okay, next one is the helical gear kinematics. That part we are going to study over here. Okay, again we already studied. Suppose one gear is having the helix angle is of alpha, second gear is having the helix angle of alpha 2. Alpha 1, this is for the input gear, this is for the output gear. Okay, to mesh, to transmit the power between two parallel shaft, this must have the opposite hand of helix. Suppose this is the left hand, it must be right hand. If it is of right hand, it must be the left hand. Only after that we can transmit the, again, that alpha 1 is equal to alpha 2. These are the two conditions need to be satisfied. Only after that we can transmit the motion between two parallel shafts. If any out of this, if this condition is not satisfied, suppose that alpha 1 is greater than this, still you can't transmit the motion between two parallel shafts. It becomes that spiral gear. Again, that shaft angle gets changed. Okay, next, how that involute tooth profile on that helical gear gets generated. What we have to do, we have to just take the base circle. We know that profile drawn above the base circle, which is referred as a involute profile. In this case, we have to consider the involute circle, or involute, sorry, here you have to consider one base circle or base cylinder, on which you have to wound one paper, and we have that front end of that we have to cut in a such a way that that angle should be the alpha, which is the helix angle. Again, if we unwrap this edge and if we trace that ends, it generates one profile which is called as the involute profile. Again, that alpha or that involute that helix angle should be in between 15 degrees to 45 degrees. That commonly used values are 15, 23, 30 or the 45. Lower, again, if you change, if the value of alpha is less, that it reduces the thrust force or axial thrust. If that alpha becomes 0, it becomes the spur gear. If we increase the alpha, that means axial thrust goes on increases. That's why in that case that 45 degrees is not recommended. Okay, again, some terminology of the helical gear that we have to study. In this, first of all, the helix gear. Suppose this is the axis of rotation, this is the axis of rotation that we have marked, and that teeth are inclined to like this. This is referred as a alpha. That angle is referred as a helix angle. Next one is the normal pitch, and say next is the transverse pitch. Just try to understand the difference between that normal pitch and the transverse pitch. Now these teeth are inclined to the axis of rotation. If you see this teeth from this direction, okay, in this direction you will find that teeth are equivalent to the spur gear. When we see that teeth that perpendicular to its direction along its orientation, then that distance between, suppose this is the pitch line, and if you have taken the cross section, again this is the pitch line. Again we have to consider this profile. This is the edge of this gear tooth profile. Again, if you have considered the intersection point of the pitch line and the that profile. Again, you have to consider the same point on the next tooth. The distance between these two, which is referred as a normal pitch. Okay. Again, same. Now what we have to do? We have to take the cross section along this. Now we have to see from this direction. You have to see from the perpendicular to the axis of rotation. This is the axis of rotation. You have to see from this direction, and we have to consider the two teeth. Okay, and again we have to take the cross section. That cross section will be like this, and you have to consider the one point, intersection point of the pitch line and the tooth profile. Again, you have to consider the same point on the next tooth. The distance between these two, which is called as the transverse pitch. One is the normal pitch, second one is the transverse pitch. Okay, that this normal pitch, which is equivalent to the circular pitch, both the are the circular pitches, but when we seen from the perpendicular direction, perpendicular to the axis of rotation, and second one is the along the tooth orientation, it is referred as a normal pitch. Again, seen from the along the axis of rotation, then it is called as the transverse pitch. Okay, that okay, when we seen from this, again we will find one angle, that pressure angle, which is referred as a phi n, which is the normal pressure angle. When we seen from this, which is referred as a transverse pressure angle. Okay, again there are some relationship between the normal pitch and the transverse pitch. Now in this case, they are separated by the helix angle of alpha. Okay, now just consider the geometry. Now this is of PT, transverse pitch. This is of PT, and I'll just mark this line. This distance, which is of PN, which is the normal pitch, and this angle, which is of alpha. If you consider the geometry, this is the alpha, this is again alpha, this is the right angle, and this is the 90 minus alpha. That's why this angle is again the alpha. Okay, because this total angle is of 90 degrees again. Okay, this is the alpha. Now if you consider this total triangle, this is of PN. I'll just write over here PN. Okay, that PN is equal to PT cos alpha. Okay, PN, which is the normal pitch, is equal to transverse pitch into cos alpha. Again, we know that pitch is equal to pi into mn. Pitch is equal to pi into mm. That's why pi into m. That's why PN is equal to pi into mn, and PT is equal to pi into mt. That's why that mn is equal to mt into cos alpha. Again, the diameters, that D is equal to, now that D, we know the transverse module, that see every time in your numerical, or every time that normal module is given to you, from this relationship you have to calculate the MT, transverse module, and that MT is equal to D by T. That MT is equal to small d by small t is equal to capital T. Again, that again MT is equal to capital D by capital T, and in this way that D is equal to T into MT is equal to T into Mn upon cos alpha, because MT is equal to Mn upon cos alpha. Again, the axial pitch, in the same relationship, if you want to measure this axial pitch, this is the axial pitch. If you consider the one point on the one tooth, again if you consider the same point on the next tooth, this is the axial pitch. If you want to find out this distance, that PA is equal to PN tan alpha. PA is equal to PN tan alpha. This is the PA. This is the PA. And this is of PN. This distance is of PN. In this way, by using this, and this angle is of alpha. Okay, that means this PA upon PN, sorry, tan alpha is equal to PN upon PA. PN upon PA. In this way, we can find out the angle between that total angle. We can find out the axial pitch. PA is equal to PN upon tan alpha. Okay. Again, there is some relationship between, if we solve these two equations, if you put these values, we can find out the relationship that tan phi n is equal to tan phi n is equal to tan phi t upon cos alpha. Tan phi n, which is the normal pressure angle, is equal to transverse tan of transverse pressure angle upon the cos alpha. Okay, next one is the center distance. Now radius, suppose this is the pinion, this is the gear. The distance between the radius of this gear is of small r, radius of this gear is of capital R, which are the pitch circle radius, which is equal to 1/2 small d plus capital D. Right now we have studied that a d, small d is equal to, or mt is equal to d by t. That's why d is equal to mt into t. That value, if you put that values, you can find out this relationship for the center distance. Next part, here we are going to study the force analysis. Okay, now just try to understand the significance of that normal pressure angle and the transverse pressure angle. Now when we are seeing from the perpendicular to the axis of rotation or along the axis of rotation, that angle shown, that pressure angle, which is referred as a transverse pressure angle phi t. And when we seen perpendicular to or along the orientation of the tooth, then there is one pressure angle which is referred as a normal pressure angle. Okay, now just try to understand the forces acting on the tooth because of that inclination. That first one is the normal force. This is the normal force, which is the resultant force. Next one is the radial force. These are the forces which are parallel to the its radius, which is towards the radius. Okay. Next one is the axial force, which are parallel to the axis of rotation. That axis of rotation like this. These forces are parallel to the axis of rotation. And one is the tangential. We will find this force which is tangent to this pitch circle. Now in this case, this is referred as a pitch circle. Okay. Now we are going to find out the relationship. Just try to find out the relationship. Okay. Now just consider on this triangle. This included angle is of phi n. That vertical is the radial force, this is the Fn, and this is the phi n. If you consider this right angle triangle, you can find out Fr, opposite side, upon hypotenuse, which is the Fn, is equal to sin phi n. From this you can find out the radial force. Okay, now we have to find out the tangential force. Now consider this angle. Now just consider, okay, first of all just consider the same triangle. You can find out this horizontal, which is called as the separation force. This horizontal force, which is called as the separation force. That separation force is equal to Fn cos phi n. Fn cos phi n. This is of Fn cos phi n. Okay. Okay. Now this is Fn cos phi n. Now just consider this triangle. This is Fn cos phi and this angle is of alpha. We want to find out this, and this is of right angle triangle. That right angle triangle over here. This is the adjacent side and this is the hypotenuse. That means here we have to use the cos alpha. Cos alpha is equal to Fn cos phi n into the cos alpha. You can find out the tangential force. Next, now we have to find out the tangential force. Next we have to find out the axial force. That axial force, in the same triangle we have to find out this axial force. That axial force is equal to Fn cos phi n. This is of Fn cos phi n. We have to find out this opposite. That means you have to use the sine of alpha is equal to Fa upon Fn cos phi. That means Fa is equal to Fn cos phi n into sine alpha. Again, radial force, that we have to find out. This is the radial force. Now consider this right angle triangle, this right angle triangle, this right angle triangle. That Fr, this is the Fr. Fr is equal to, okay, Fr is equal to Ft. Now this total angle, this angle is of phi t. This angle is of phi t. Just consider this angle phi t, which is of Fr is equal to Ft tan phi t, which is the transverse pressure angle Ft, that I have not mentioned, or okay, and that Fn is equal to, now that tan phi t is equal to Again, this Fn, if you want to find out the relationship between this Fn and the Ft, that we can find out here, that Fn is equal to Ft upon cos phi n upon cos alpha. Okay, that relationship that already we have derived over here. Okay, no need to repeat this. In this way, we can do the force analysis of the helical gear. That Fr is equal to Fn sin phi n, Ft is equal to Fn cos phi n cos alpha, Fa is equal to Fn cos phi n into sin alpha, and Fr is equal to Ft into tan phi t. Okay, in this case, that normal pressure angle will be given to you. From this, you have to find out this relationship. Again, that torque will be given to you. Torque is equal to, or the power will be given to you. Power is equal to T into omega, and T is equal to Ft into R, which is the tangential force. From this power, R and omega will be given to you. You have to find out the Ft, and from that Ft, you can find out, from this Ft, you can find out this Fn. Okay, from this Fn, you can find out this Fr, and from this Fr, and Fn, you can find out the axial force, or we can find out the all the forces if we know the any one forces, because these all are the dependent on the each other by the geometry. Now last part, which is the virtual number of teeth. Now when we see in perpendicular or along the tooth orientation, we seen that teeth are equivalent to the spur gear, and if you make that equivalence, if you want to find out the total number of teeth on that gear, for that you have to use the concept of the virtual teeth. Okay, now if you see the perpendicular to that or along the orientation of the tooth, that this radius is this, which becomes the ellipse, and for the ellipse, that equivalent radius is of this diameter. Earlier that diameter is of d, and if you see perpendicular, if you say take that cross section, that new diameter, which is equal to Re, or the equivalent diameter, is equal to d upon 2 cos square phi, that phi which is the that helix angle. Okay, now I want to find out the equivalent number of teeth. For the equivalent number of teeth, we know that module is equal to d by t, that means mn, normal module, is equal to d by t. In this way, we can, by putting that value in this equation, you can find out the transverse module. Okay, number of equivalent number of teeth. Again, we know that mn is equal to mt into cos alpha, or d is equal to mt into t, that we know. By using this relationship, we can find out that if we replace this d by mn, we can find out that te is equal to t upon, that means earlier it is having the t number of teeth, t upon cos cube of alpha. In this way, we can find out the virtual number of teeth on the for the helical gear. Okay, in this way, what we learn in this total lecture, we have started with the introduction of the helical gear. Next, we move to the center distance. Again, before that, we have studied the terminology of the gear. See, few important things that you should know. To mesh the two helical gears, they must have the same helix angle and the opposite hand of helix. Again, they must have the same normal module. Okay, in case of helical gear, they are again having the same helix angle. They are again having the same transverse module, but any type of gear, they must have the same normal module or the same module. Only after that we can mesh the two gears, and you will find the smooth operation, and they are satisfying the law of gearing. In this way, we are going to finish this lecture. Thank you for your patience listening. Thank you.